This one, oh, we can answer this part down here. Are the original and the dilated triangles congruent? No, are they? Why not? Why would they not be congruent? Yeah, I wouldn't even talk about that. With different triangles. That's the first part of it. Are the two triangles similar? And by similar, we mean, do they have the same angles, yes or no? Do the sides have to be an exact match? No, they just need to be proportions, yeah. So, what we know, are the two triangles similar? Yes. The reason being, angles are congruent, and the sides are I'd say the sides are proportional or proportionate to each other. Now, I don't know if you've done this before. Would you do something where like A over B equals C over D, and then you cross multiply to get an answer? Have you worked with fractions like that before? Okay, so hopefully we know you can solve something like this. X over 2 is equal to like 5 over 10. Right? Did you remember how to cross multiply and go from there? You compare one. Okay, that's how you go through and solve running missing side in a proportion triangle. This is where it gets the most interesting, though. It says find the area of that triangle. And I didn't show, oh, sorry, we didn't do this question. Is a dilation and isometry? Now, this came up, and it was an exception. How many of you know right now, off the top of your head, with certainty, the definition of isometry? How many of us then don't know what the definition of isometry is? So instead of turtling, which is what happens sometimes when you see it, you have to go the rest of your life without knowing what it is. But please, if you can tell me how, if I do this, yes, you could go through and tell me what an isometry is. Yeah, 3 people. I give you 60 unfettered seconds. Oh. Does it cost money? Okay. So, here's what we're going to do. I'm going to give you guys 60 seconds, and I'll tell you when. At which point, you can take out your phone. Now, you need to come up with, and you may need to do a little bit of poking around. Is the first site from Google always the best? Not necessarily. You may need to poke around. You've got to be able to answer the question. What's an isometry? And by the way, you might want to look it up. What word should you put in that might make it so if it has other definitions, you just use this one? Yeah, put geometry in after. Okay, so, you ready? You're going to be our official timekeeper. There's a lot of pressure, okay?
Me?
Yeah.
Oh.
Ready? You get to the button. Go. You got 60 seconds. We'll call on you. Point and stare and laugh if we don't know. We're at 50 seconds. Look it up. Let's see if we can go through and get. Poke around. You've got 37 seconds. Let's make sure we're going through and giving out the best answers that we can. Looking for what it means to be an isometry. 20 seconds left. We find the definition. Things that are important about our definition would be things that we, characteristics that we would use. Somebody, by the way, gave an explanation last time. It was super long. It was weird because as they were reading it, I just saw people go, oh, I get that. It was language beyond what I'd expect you to know. You just pull keywords out of the definition, you're good. All right, you've got a definition for us. What do we know about an isometry? At least let me use it. No one found any. Nothing. this person knows something. Hopefully. Just anything you want to say. It's okay. What did it say? Read me the definition. Yes, I mean, yeah. You don't need to take it and put it away. These are not like, it's not like a nuclear weapon. You can keep your phone out. If no one doesn't disengage your learning. Yeah. So we need big thing to take out. Yeah, it preserves length of side, right? So is a dilation an isometry? Yes or no? Why not? There you go. Sides change length. That was tough. How many of you found a definition similar to that when you were going through and doing your reading? Okay. How many of you clicked, was it the first definition of S1? Yeah. Okay. How many of you went and looked in Google Images, by the way? Poke around in images. That always helps. You will find a picture of what you're looking for. And you don't have to visit 800 websites and you just go, oh, this is it. You can make the visual connection better than you can with words. Now, the other part that we have not talked about yet, and maybe some of you will be very good with this, I had about 4 people, I think, last period that ended up figuring out and knowing how to do this. Look at the figure that's there right now. The task, or is it question number 6 is our next one, about the area? 8, sorry, is that the next one we have to answer? Okay, so want the area of triangle ABC and then A prime, B prime, and C prime. So I only have ABC in front of us. Who can tell us anything that they know or can remember about how we find the area of this, or how many squares are on the inside? Think about the shape, anything you want. We're brainstorming here. There's no firing squad if you're wrong. No one judges you if you're wrong. If someone judges you, then they're a garbage person. Look at what's there. Try to make that connection. How could I figure out what this area is, or anything that could help us out? That's the area formula for what shape. Yeah. Now here's our problem. I would normally say that's perfect and rip into it. Why can't I do that here? Yes. And they're not like integer values. It's nothing that I can sort of obviously see. So that's not wrong though, and don't forget what she said, because we're going to need that. That's sort of step 2 though. I need something else. Does anybody know how I can figure out the area of that awkward, non-conformist, weird triangle? Now it's kind of awkward. What shape does it have? Now, got a bunch of squares over there. Look at the square. Shape similar to a square. Yeah. Watch what she's telling us to do right now. This is the difference, and this isn't to judge, but understand. There needs to be a certain level, and it's not to judge you all, you misinterpret it. There needs to be a certain level of problem solving you all. Meaning, if something's put in front of me, and I haven't done it before, do I shut down and say the world can't do it? No, everything that we did, there was some answer to it. The problem that we had here was we were working with a shape that we weren't good with. Now when I draw that rectangle, can I find the area of the rectangle? Yes or no? Yes. So I go through and hands up, please, when you can tell me what the area of the big rectangle. And draw that rectangle right now. What would the area of our big rectangle be? 15. So I write that over the side. So the big area is 15. What do I still need to do? You're not wrong, the sides are 3 and 5. So somebody else besides Elisa, she gave us this part and gave us our process. I found the area of the big rectangle. What else needs to be done though? We have to try something. You could now that would give us the area though half of that thing. You can't assume that it's only like half on the other side. So now you're trying to find the area of this. Yeah. I'm trying to find out how much space this would be. How many small triangles do you see in that picture? Holy cow. How many small triangles do you see in that picture? 3. This shouldn't be tough. We got 3 small triangles. One here, here, and here. And can I figure out how big each of those triangles is? Yeah, this one has a base of, how big? 2 here and 3 here. This one here has a base of 3, height of 2, and this is what, 5 and 1? So what's the area of that bottom triangle going to be? Hands up, please, when you can tell me. We don't need, we should all be able to do this one pretty quickly. What's the area of that bottom triangle going to be? Well, 3. Why? What'd you do? Which is what you told us to do earlier. So this one here has a value of 3. That's how much area that one is. We still have 2 others. Maybe we don't need to. The area of this triangle going to be 3. It's the exact same as the one on the side. What's this triangle here going to be? 2.5. So how do we find the area of our triangle? 15 minus 6 minus 2.5. We don't need a calculator to do that. What's 15 minus 6 going to give us? 9 minus 2.5 more. 6.5. So what's the area of this triangle? 6.5. Go in right now, find the area of the big triangle. The exact same process applies. Find the area, please, of the big triangle. Go through, find the area of the big triangle. Know if these guys, do they overlap at all? They do, sorry, I thought I was here enough to be apart. And we said the area of this was what, 6.5? That's what we're going to find out. We're going to see why. Don't assume. We'll see why. Who can tell us what the area of the big triangle ends up being? Hopefully we've got a rectangle around it. So if you subtract the 3 small triangles that are in there, who's got a value for what the area is? You got one person? Becky, what'd you get?
13.
Not going to be 13. What did you get for the big rectangle?
It's off my grid.
Okay. You keep doing it. You can tell us please what they got for their area. Now, How many of us got that the area should come out to be 26? Okay, that shouldn't be a struggle for you. You go through plot, your rectangle around, and then was it still 3 triangles that we needed to subtract? Is that right? Okay, and it's still 1/2 base times height. Your question. If we go through and do this out, some of us might have thought, well, wait a minute, what was my dilation factor box? 2. So what would I expect to happen with the areas? Multiply by 2, but that's not the case. What do we have to multiply the area by? Take a look at the numbers again. What do I have to multiply the area of the small triangle by so I can get the big triangle? 4. Anybody know why? So don't think of it even in terms of a triangle. Think about general shapes. You're not wrong that there's that multiplication by a half that's in there. And when we're dilating by 2, it does have to do with that 1/2. We'll even show you how it plays in algebraically in a second. So as you're doing that, the thing you have to understand is, if I'm trying to increase the area of a triangle, think of it like a square instead of a rectangle instead. So you've got measurements here of like our original one was like 3 and 5, right? So right now, what's the area of this going to be? 15. Now I'm going to dilate this by 2. So that would mean this side becomes 6. This side doesn't stay 5. What's this side going to have to become? 10. So watch what happens. If I only double one of the sides, what would my new area be? So this is double here. But not only did I double that one side, I also doubled this side. So really this becomes 60, which means this is multiplied by 4. And why would it be multiplied by 4? Why by 4 and not by 2? You got to do it to both sides. Yeah. So that's what ends up happening with it. And actually, one of the things we showed the other group from yesterday was the part making brownies. There's like a whole chapter on it. Because it's an easy way to get you to understand area and edges, inside values versus outside ones. Here's my original pan. It's 11 by 7. If I'm going to double the dimensions of the pan, how many packages of brownie mix do I need to add? I'm going to need 4 to fill that up, not 2, because if I only doubled one length, I would need 2, but you're doubling a double. And what's double a double? 4. 2 times 2 is 4. Now we got one other thing to consider. We can even talk about now as long as we're doing it. Think about a cube. And think about volume. So if I had something like this, and this was my original with side length of 1, what would the volume of this be? 1. Now, what happens when I double the dimensions or dilate this by 2? What would the new figure look like? Well, all the edges of the cube would have a value of what? 2. Hands up, please, if you can tell me what the volume of that figure is going to be. One person? What's the volume of that figure on the side of the cube with all the edges being 2? Yeah. So, before we said if we double a flat area, just for area, we dilate it by 2, you would multiply the area by 4. Now, how do I go from these dimensions over? If I know the volume is 1, I double it in each side. It's really 2 to the third, because didn't we double each side? What's 2 to the third going to equal? Holy cow, did you just math it right? What's 2 times 2? Times 2 again. Okay. So that's what our scale factor ends up being. If you go through and dilate a 3-dimensional figure by 2, everything starts getting really, really big really, really quickly. and this actually came up. Did you guys look at ancient Rome or like Greece before, like in world history? Like in sixth grade? Okay. So the reason that that comes up is they actually had a thing called the Colossus of Rhodes, which was a big giant statue that the Athenians built over they beat Sparta. Like a bunch of Greek cities fought each other and won. So they decided they're going to build a statue of some guy, and they really wanted it to be awesome. So they said, hey, double how big it was before. Except the city then almost went bankrupt trying to go through and build this thing. Because if you double each of the dimensions, how much more expensive is the project going to cost? Careful, it's not two-dimensional, it's three. So you're building a statue now that's twice as tall, twice as wide, and length, width, and height. Twice the length, twice the width, twice the height as before. So 2 times 2 times 2 is how much? So they needed to build a statue that was going to be like expensive beforehand. When you double the size of it, how much more does the cost go up by about? 8 times the cost. So all of a sudden they realized pretty quickly they made a really, really big mistake. And one of the things that's kind of interesting also is they start talking about, it's kind of interesting because it's a new-ish book. Let's just say right now, I think you talked about the rock. It's like the person that this gets done on. If we doubled every person's dimensions, let's say if I doubled let's say I doubled your height and your dimensions, that means you're going up by a scale factor of 8, which means like if you weighed 100 pounds before, what would your new weight be? 800 pounds. But something else starts to happen. You have to hold up 800 pounds. What's going to happen to your bones? Then you're going to be so heavy that you wouldn't be able to stand up. You'd be like a giant block. You'd never be able to walk. It ends up being that, like us right now, believe it or not, you all are pretty much as close to achieving your biological maximum. Like, we can't get that much taller than we currently are, because you're eating better and things like that. You'll go through growth spurts, but people aren't ever going to, like, naturally be 7 feet tall. That doesn't happen a vast majority of the time. Even if you go back and look, when our country got started, how many of you are 5 foot, above 5'6"? Okay, so if you're above 5'6", you would be a giant. That's like, you'd be towering over like I think George Washington was like 5'10", and they thought he was a sequoia, like a huge, tall person. Why were people really short back then? They didn't eat right. Like, you know how we have like potatoes and stuff like that? We didn't have potatoes. We ate essentially the same thing every day, all day. Like a lot of corn and like and it talks about like why elephants have great big giant legs. Are elephants heavy or like heavy? So like elephants compensate for it. Cats have super thin legs. Why? They're super light and small. Yeah, same thing happens with birds. The other one is an ant. Ants can hold up to like 50 to 60 times their own body weight, just due to the fact that they're designed really, really well. People could never be this sort of strong. But ants go through, and this is what we were talking about. Ants go through and they get an award because they're super, super strong relative to their size. They'd be like the best fighting champion ever. But little things like water, like kill them. Like ants float away, and then they die. So is it really good that they're super like efficient and strong? Kind of, but until like one drop of water comes along, they go down. So that's what under there. We had last time we left off on I went to page 5. Or no, what page? We were on page 5 last time. Sorry. What page is this? What do you say, 15? Okay. Slide over, guys, to 15. We're going to go through and plot this stuff out. The biggest thing that we need to know is we're going to work right now with some compositions, which means you're just doing 2 transformations at once. And it's not tough. The only thing you have to remember, you normally read going from your left to your right. So that means this way to this way. When you do compositions of transformations, you go, the notation would be this one gets done first and then the one on the left. So it goes from the right to the left, not left to the right. Let's start off with our first one though and do this out. What's the image of 5-1 under a reflection followed by a rotation? So let's start off and let's label A, I guess, is the point 5-1. So go on your paper. Let's label point A. We'll label it as A. And I think it was 5-1 over 5 up 1. So that's what I'm starting with, and I'll call it point A. What do I need to do first? What did it say in the narrative if you're just reading it as a sentence? What does it tell us to do to that point first? So what's that ordered pair going to be? So let's go show that. And I'll label it as A prime because it's after the first transformation. A prime is the point 5, negative 1. And then the next transformation, Sam, what does that ask us to go through and do? So it doesn't matter whether you do clockwise or counterclockwise, because 180-degree rotation doesn't matter which way you go. I would advise you to go clockwise, which is the way we normally go, which means you go the direction that the clock goes. It's going to be in quadrant 2. Hands up, please, if you can tell me what the ordered pair would be after I did that rotation of 180 degrees. You can turn the paper if you need to. The point 5-1 is going to become what when I go over into quad 2. Emmy, what do you say? Go back 5, go up 1, and we'll call that A double prime is negative 5, comma 1. Now, it specifically wants us to, let's make sure we've got this. What is the image of it? So, what's the after point? A double prime would have a value of, if you said negative 5, 1. Is that right? Okay. Do we have questions on that part? Now, the second thing is we did how many transformations here? 2. The first one that we did, Anna, what was the first transformation out of those 2 that we did? So do we need, if it's a reflection on the x-axis, do we use a capital R or a lowercase r for reflection? Lowercase r, so we're going to write it out. And it was x-axis, right? So reflection in the x. Now, some people write x-axis. If it's not there, assume it's the x-axis. On the point, what was our original point, 5-1? Is that right? Okay. We also did what? So now I'm going to leave an open circle here because there was another transformation that was done before that one. Or sorry, after that one. We did our reflection. What else did we do here? So is that a capital R or lowercase r? There we go. What does this indicate? This transformation is the one that is done first. Make sure we understand that part. Questions on that? All right, so we're going to give a couple of these a try. Let's look at example number 1. It's calling for 2 transformations. Caleb, what's the first transformation that you would go through and do in example 1? Okay, so if I dilate that point by 3, what would I be left with? What would you have? Okay, so that leaves me the coordinate negative 6, comma 9. And now what do you do to that point, Caleb? So I'm going to reflect over the y-axis the point negative 6, 9. So think about that. You can plot it out if you need to. You've got the point negative 6, comma 9. What is that going to be after I reflect it over the the y-axis? Jason, what would that ordered pair become when I take negative 6, 9 and flop it over the y? Okay. And that's your final answer. Was that tough for us? I hope not the toughest thing. Questions on that one? Let's try number 2 then. Marlene, what's 2 say to do in the beginning? What's the first transformation we would do? So I'm going to reflect over the line y equals x on the point 61. And what does that give me? It's going to give us the ordered pair 1, 6. And do you know what you would do after that? And I'm going to reflect the point 1, 6 over the y-axis. And after I reflect 1, 6 over the y-axis, Mitchell, what coordinate would I be left with? So that would be the point -1, comma 6. Do we have questions on that? You can draw them out if you need to. Reflecting over the y-axis changes the x and not the y. Next one that we'll go through and give a try is number 3. Looking at 3, Ava, ask what would be the first thing we went through and did. Great. And if I start off with the point 2, 3, what's that going to become? Perfect. 2, -3. And then after I did that, Chris, what would I do next? So I'm going to reflect it over the line x equals 4, and the point's 2, -3. Now, some of you are somehow a lot better at this than I am if you're not drawing it out, but all of you should be drawing it out. Like, I don't get how you do it. Okay. Go over to the margin, give yourself x, y axes. We've got the line x equals 4. Tyler, x equals lines. Do they go up and down or side to side? So if x equals 4, I'm going to draw that here. This is x equals 4 if we need it. We've got a point to plot, which would be 2, -3. Is that our point? Okay. Now 2, -3 is going to get reflected over that line. So we're going to be in quad 4. What's our new coordinate going to be? That B? Yeah, if I'm looking the distance from here to here, it's 2 units, so I go 2 units over again, which means I had 4 total. And you said it worked out to be 6, -3, which is correct. Do we have questions on that one? Right now and try 5 on your own. Plot it out if you need to. Try 5 on your own. Ava, see what's the first transformation I would do on this point of 4, 0. Great. Now, I've listed it out. When you turn this 90 degrees, that puts us right here, just so you know. See how it falls between 2 quadrants? That's called a quadrantal. Just so you're aware, it comes up in algebra 2, not now, but you can't write. If it's between 2 quadrants, it's called quadrantal. What would our coordinate be when we rotate 90 degrees? Perfect. We get 0 to 4. What would we go through and do next, Madison? Okay, and what's that going to go through and be? Questions on that one? Are these difficult? Okay, and let's slide over. I think 2 pages where it says homework at the top. Is it 2 pages? Okay. Let's start off with question number 1. We didn't have any of these, but hopefully we can handle it. What's the first thing I would do in number 1? What would we do to start off question number 1? Okay, so I'm going to do a translation, and I'm going to move it to the right 2 and then down 4. So what would the new ordered pair be after you do that to the point 4, 5? You're right. Yep. Now, we've got the point 6, 1. Zach T, what gets done next? and we're going to do that to the 0.61, so what are you going to get then? That's the same, by the way, as doing what transformation on the original. Notice this is the same thing twice. You also could have just said this is the same as what on the 0.45. Take a look at what's there. What can I go through? Oh. What could I go through and do if I'm trying to get this done in one single transformation? Yeah?
Just add 4.
Close. Add 4 to the x and what to the y? So you need to have an x and a y on it. We have questions on that part? All right, then let's say we do number 3 next. If you get done with that one, slide down and do number 5. Emily, what do we get after we do that translation? And then we're going to perform our reflection on that point. What do you get after the x-axis reflection? Yes. We have questions on that one? Next one up after that. What would you do first, Sam? What do you think you do first in number 5? Yeah, let's do our rotation of 90 degrees first. So we're going to rotate 90 degrees to point -2, 5. So I look at the graph of that. -2 is back 2, up 5. So this would be the point -2, 5 here. So when I rotate that, just so we're clear, I do this as maybe we would go back 2 and then up 5, right? So now, what would that look like if we did it in the next quadrant? Well, I have to go down 2 and back 5, isn't that right? Doesn't it become, this is down 2 and back 5. This is the point -5, -2. And notice, at no point in this did I have to go through and memorize any formulas. We just go through and you start drawing. This comes out to be the point, let's put it at -5, 2. And then to that point, I need to reflect over the y of -5, 2. So what do I get if I do that, M? So the point -5, 2 reflected over the y. Careful. This one here is going to get reflected over to here. This was -5, -2. Perfect. With all that tough. So, I'm going to do another. And which one do you want to do next? 2. We'll look up topic 2. First thing, reflection in the x-axis. There, what's that going to be? We'll give us a reflection in the x-axis on the point -3, 4. Now, on that point, I need to reflect it over the line y equals 2, which means I'm going to go through and draw that out. Y equals lines go side to side. That's my axis. This is the line y equals 2. Where's our point going to be? -3. So go back 3, down 4. That's the point -3, -4. So our other point then is going to have to come up and be in this area somewhere. which half of that ordered pair should you automatically know? You know the x or the y on this point right away. The x, yeah, the x is still going to be -3. So how far was it to go from -3 up to the line y equals 2? How many spots was that? I went up from -3, 4 up to here. We said was up 6. So now let's go up 6 more. Add 12 to that. What's our new y value going to be? Nope. We're at y equals 2. You got to go 6 more above that. -3, 8. Questions on that one? Are these going to be really, really repetitive and redundant? Yeah. How many do you have to finish? 4? Okay. Do those 4. It does through question number 8. These are grids down below. How many of us have less than 2 left? Whatever we can do, finish up through 8 for homework. And one other thing, do we have class together on Friday? We don't see each other on Friday? Okay, thanks. Have a good day, guys. Have a good day, guys. We'll see you all tomorrow. Have a great rest of your day.